Bright Tuty. Every student matters.
As we have discussed about the prime numbers, composite numbers, so now we are going to do some practice of on the same concept using some questions. So here are the questions. As you can see, the first one is a very simple question. It is asking you what is the sum of any two odd numbers. Everybody knows what are odd numbers. Odd numbers are the numbers which are not exactly divisible by 2. They start with 1. So sum of any two odd numbers, like you can take any example of two odd numbers. Suppose I take 5 and 3. The sum is even. You can take any other number. Suppose I take 21 and 7. Both of them are odd and the answer is 28. That means the sum of two odd numbers will be even numbers. Okay, so what is the question? That what is the sum of any two odd numbers? It is even numbers. In the B part, even numbers we have to take, like the what is the sum of two even numbers they're asking. Let's take two even numbers. Suppose I take 4 and 6, it gives me 10. And if I take suppose any two other even numbers, suppose 14 and I take 16, so it will give me 30. You can take any other like 12 and 32, right? So it will be 54. So let's take another two even numbers. Suppose 12 I take and then 36 I take. So what will we get? 6 and 2 will become 8 and 3 and 1 will become 4. So we get 48 as the answer. So what do you observe in all the cases? When we are adding even numbers, the answer is even. Even when we are adding two odd numbers, the sum is always going to be an even number. Clear? Moving to the next question now. Here we have to state whether the statements are true or false. So we can take up some examples and can try proving them. And then we will be stating whether they are true or false. Let's focus on the first one. The sum of three odd numbers is even. So what are they saying? When you add three odd numbers, the sum is even. Let's try out. I'll take three odd numbers. Let them be 3, 5 and 9. All of the three numbers are odd. Add them. 5 plus 3 is 8. 8 plus 9. 8 plus 9 would be 17. Clear? As you can see, the sum of three odd numbers is coming out to be an odd number. 17 is an odd number, not exactly divisible by 2. So what is this? This is a false statement. The sum of three odd numbers is odd. We got the answer as odd. So it is a false statement. The next statement is the sum of two odd numbers and one even number is even. Obviously. Why obviously I said? Because we have discussed in the previous question, if you see, okay, in the previous, if you see, when we were adding two odd numbers, we were getting the answer as an even number. Here, even plus even will always give us even numbers. In the first one we have discussed, when we add two odd numbers, we get even numbers, and in an even number, if you add even number, we get always an even number. So here also, students, when you will add two odd numbers, the answer will be even, and one more even number you are adding to it, so that will become even. So this is a true statement. You can try out with some example. Suppose I take 1 and 3, which are two odd numbers, and an even number, let it be 2. So 1 and 3 is 4. 4 plus 2 will give us 6. So this is an even number. So this is a true statement. The product of three odd numbers is odd. Let's try multiplying three odd numbers. So let's take 5. Let's take 7. And one more odd number we can take up. Let's take 11. So 5 into 7 is 35 into 11. Let's multiply 35 with 11. 11 5s are 55. Carry will be 5. 11 3s are 33 and 5 gives us 38. It is an odd number. So yes, this is true. You can try out with one more example, like 1, 3 and 5. They all three are odd numbers, and when I multiply 5 3s are 15. So odd I am getting. So yes, this is a true statement. If an even number is divided by 2, when you divide an even number with 2, the quotient is always odd. Let us take an even number. Let it be 18. If I divide 18 with 2, what is the answer? You get the answer as 9 of quotient. It is saying it is always odd. Let's try with 8. If I try with 8, 2 fours are 8. I am getting an even as well as sometimes odd number. So, but they are talking only about the even number. When an even number is divided by 2. So, 18 and 8, they both are even number. And I divide by 2. In one, I am getting the quotient as 4. In one, I am getting the quotient as 9. So, it is not always odd. Okay. It can be odd, but not always. So, this is a false statement. The next one, all prime numbers are odd. It is false. I hope you remember we discussed that 2 is a prime number. Yes, 2 is a prime number. Is it odd? No, it is an even number. 2 is an even number as well as prime. Prime numbers do not have any factors. Is this true? If we recall the definition of prime numbers, the prime numbers are the numbers, or the numbers are called as prime numbers when they have only two factors. One is the number itself and 1. So here we say this is false. At least two factors they will always have, the number and 1. Sum of two prime numbers is always even. Is this right? If I take two prime numbers, let us take 2 and let us take 3. These are two prime numbers, 2 and 3, but the answer I am getting is odd. So it is not always even. I can try with 2 and I can try with 7 because 2 and 7 are always like they are prime number. So when I add them, I get the answer is 9. So I'm getting odd answer. Okay, they're saying it is always even. Will we ever get an even number? So we are going to get odd numbers only. So this is false. Okay, the next one, 2 is the only even prime number. Yes, 2 is the smallest as well as the even prime number. So this is a true statement. Rest all of the prime numbers are odd. All even numbers are composite numbers. This is not true because if we take the case of 2, 2 is a prime number and it is even. It is not a composite number. So because of this, it will be false. The product of two even numbers is always even. Let's try figuring it out. I'll multiply two even numbers. Suppose 2 and 4. Yes, I'm getting the answer as 8. And if I try with suppose 16 and let it be 10, both of them are even numbers. It is giving us an even number as the answer. So yes, it is going to be even. It is a true statement. Clear? So this way, applying our knowledge of prime and composite numbers, even and odd numbers, we are able to do all the true and false. We are always able to tell or state whether the statement is true or false. Let's move to the next question. This is the question and it is asking the number 13 and 31 are prime numbers. Okay, the number 13 and 31 are prime numbers. Both these numbers have the same digits. Yes, we can see 13 has two digits, 1 and 3. 31 has two digits, 3 and 1. So both of them are prime first thing and they have the same digits. Now they're asking find such pairs of prime numbers up to 100. So we have to figure out what all such pairs other than 13 and 31 can be formed. Both of the numbers should be prime and they should use the same digits. So if you see, if you will have a look on the prime numbers list up to 100, you will start writing it as 2, 3, but two digit numbers. Okay, same digit should use 5, then 7, then after 7 we have 11, 13, then 13 we have already discussed, it is 31 given. Then after 13 we have 17, then we have after 17 we have 19 first. Okay, 19 we have. So these are the prime numbers. You can write them down, and when you will after 13, if I try for 17, the reverse of 17, this is a two-digit number, okay, and it is using the digit 1 and 7. So if I reverse it, that will be 71. So is 17 a prime number? Yes, I have written it, and it is using the digit 1 and 7. 71 is also a prime number. It will not be divisible by any other number other than 1 and 71. So 71 is also a prime number. So this is another pair that we have found, 17 and 71. Then when you keep figuring out, like after 19 you will reach to 23, so when you reverse it, 32 will not be a prime number. So you can write down all the prime numbers in this way, like 23, then you can write down 29, but 92 is not a prime number, the reverse of it. So you have to write down, students, all the prime numbers. So in this way, if you write down, the next number that you will find is prime and its reverse is also prime. That means it is also using the same digits. So the next number would be 37 and the reverse of it is 73. So they both are prime numbers and they're using the same digits. One more we have, that is 19. So 19 reverse is 91, but 91 would be divisible by 7 as well as, you know, another number. So it will not be a prime number. 91 is not a prime number. So figuring out, you have to find other pairs. So there is one more pair which will use the same digits and will be prime. So that is 79. Okay, and the reverse of it is 97. So these two are prime numbers and have the same digits. Let's start with the next question, and here it is, question number 4. It is asking, write down separately the prime and the composite numbers less than 20. So we have already discussed in the previous question, what are prime numbers? The numbers which will have just two factors, 1 and the number itself. Okay, so what are composite? The numbers which are not prime. So first we will figure out what are the prime numbers less than 20 we have. So less than 20, we have to write first prime numbers. I'm writing, and we have to list them separately as mentioned in the question. So prime numbers less than 20, starting with 1. Okay, I'll make the heading for composite, so we will find side by side the composite numbers as well. So 1 is neither prime nor composite, that we have discussed. Starting with 2, 2 is a prime number, 3 is a prime number, 4 is not a prime number, that means it will come into the category of composite numbers. 5 a prime number, 6 is not a prime number because 6 is actually divisible by 2, 1, 3 and 6. So it has many factors, okay, not just 2, that is 1 and the number itself. So 6 is also a composite number. 7 prime because doesn't have any factors other than 1 and 7. 4, 6, 7, then 8. 8 will be divided by 2 as well as with 1 as well as with 8 as well as with 4. So there are many factors, not a prime number. 9 will also be divisible with 3 other than 1 and 9. So it is a composite number. 10 will also be divided. So 10 is also a composite number. 11 is a prime number. 12 is a composite number. 13 is a prime number. 14, you can see 14 is divided with other numbers like 2 and 7 other than 1 and 14. So it is a composite number. 15 will also be divided with 5, with 3, with 1. So it has many factors. Starting with 16, 16 will also be having many factors other than 1 and 16. And then I start with 17. 17 will not have. 17 is a prime number. 18 is not a prime number because 18 is divisible by 118 plus 3, 6, 9 like that. So starting with 19, 19 is a prime number. It is not divisible by 1 and 19. Like it is not divisible by any other number other than 1 and 19. So 19 is a prime number. So less than 20 means we don't have to include 20. So these are the prime numbers listed here and these are the composite number listed here. So that's all we had to do in the question. Let's move to the next one. It is asking, what is the greatest prime number between 1 and 10? When they say between 1 and 10, I don't have to include 1 and 10. When they write from 1 and 10, then I have to include 1 and 10 as well. So between 1 and 10, the numbers, first of all, I'll write the numbers 2, 3, 4, 5, 6, 7, 8 and 9. These are the numbers between 1 and 10. Out of these, I'll calculate the prime numbers first, or I'll list down the prime numbers. Out of these numbers, the prime numbers are 2, 3, 5, 7. What is the greatest prime number out of these? 7. So 7 is our answer. 7 is the greatest prime number between 1 and 10. Clear? So this way you figure out. And the next question says here is express the following as the sum of two odd primes. So the first part is 44. So you need to figure out, like, you have to take two odd primes and express 44. What do you think? What we have to add in 3? 41. What do you think about 41? 41 first is an odd number. Yes. And we need odd prime. Is 41 a prime number as well? Yes. So we can write 3 plus 41 and it will give me the sum 44 as the sum of two odd prime numbers. B part, that is 36. So now to figure out for 36. So suppose I start with 3, that is an odd number. Okay, with 3 I have to add 33. 33 is not prime. Then I start with 5 with 31. Yes, they both are odd and prime, so we can express 36 as this. C part, that is 24. So for 24, if I start with first C3, because 2 I will not take, that is a even prime number. So with 3 if I take, I have to add 21. This is not a prime number. With 5 if I take, how much I need to add in 5? 19. Are they both odd prime numbers? Yes. So 24 can be expressed as 5 plus 19. Now the next number that we have is D part 18. Okay, so if I start with 3, you know how much do you have to add to 3? 15. 3 odd, 15 odd, but 15 not prime. So cancel this one and start with 5. With 5, how much do I have to add? 13. Both are odd. So 5 plus 13 will give me what? The sum as 18. Are they both odd? Yes. Are they both prime? Yes. So this is how we express the numbers as sum of, you see, all of them are even numbers. We are expressing even number as the sum of two odd prime numbers. Clear? Let us do this question now. It is asking, give three pairs of prime numbers whose difference is 2. Also, they are giving a remark here. Two prime numbers whose difference is 2 are called twin primes. Yes, so you need to remember this. If we have prime numbers, okay, and the difference is 2, so we call them as twin primes. So we have to give three pairs. Okay, three pairs I have to write down, and there should be prime number. The difference should be 2. So the first that I can think is 3 and 5. Yes, 3 and 5, they both have the difference as 2. What do you think about 17 and 19? Are they both prime numbers? Yes, and their difference is 2. So they are twin primes. Can you think about some other number? What do you think about 11 and 13? Are they both prime? Yes. Is there a difference 2? So yes, the difference is 2. So this is how we have written three pairs of prime numbers whose difference is 2. Clear? Moving to the next one. Here I have to figure out which of the numbers are prime. You can see there are 4 numbers given here. Okay, first is 23. Let us form the factors of 23. 1 into 23, these are the only two factors, 1 and 23. So this is a prime number because it doesn't have any factor other than 1 and 23. The second part is 51. If I find the factors of 51, I will write 1 into 51. With the 2, 51 will not be divisible. If I divide with 3, I will get 17. Yes, so you can check, see, 1, 3, 17 and 15. So it is not a prime number. These all are the factors. So just we can cancel it here only. C part 37. For 37, we see there are only two factors because we do not get 37 by multiplying any two other numbers. So yes, this is a prime number. It has only two factors, 1 and the number itself. What about the D part 26? It is an even number first of all, and as we have already discussed that 2 is the only even prime number. So 26 will definitely not be a prime. What is another way of proving 26 as a prime number, as a not a prime number? So you can find out the factors 1 into 26. Then with 2 also it will be divisible 13. You see more than 2 factors 1 and 26 we are having. So this is not a prime number. It is a composite number. Moving to the next question, they are asking write 7 consecutive composite numbers less than 100. We have to write 7 consecutive. That means consecutive is one that comes after another, just after one. So in continuity we say. So I have to write 7 composite numbers. Composite numbers are the numbers which are not prime. That means they will have more than 2 factor. They will have more than 2 factor in what way? Like with the what about other than the number and one, they will have more factors. So less than 100 we have to write so that there is no prime number between them. They should be consecutive and there should be no prime number coming in between them. The numbers that we can write is 90, okay, and 91, 92, 93, 94, 95, 96. Yes, these are 7 composite numbers. That means they're coming one after the another and there is no prime in between them. See, 90 has more than 1 and 90 as the factors, has more factors other than two numbers. 91, if we see, also has more than two factors. 91 is also divisible by 7, as you can see, and it is divisible by 1 and 91, so it will have more than two factors. 92 is an even number, divisible by 2, divisible by 4 as well, with 1 as well, and 92. 93 other than 1 and 93 is divisible by 3. 94 other than 1 and 94 is divisible by 2. 95 other than 1 and 95 is divisible by 5. 96 is divisible by 2, divisible by 8, divisible by 4, divisible by 1, and 96. So other than these two, 1 and 96, it has more than two factors. So this is also a composite number. As you can see, this is the list of numbers and they're less than 100 and they have factors less than, oh sorry, they have factors more than 2. These are composite number and there is no prime number in between them. So this is the list of the 7 consecutive composite numbers. Clear? Moving ahead, we have to express each of the following numbers as the sum of 3 odd primes. Keep this in mind, 3 odd primes and 21 is the number. Okay, starting with 21, if I start, because I don't have to take the odd prime number, so 2 is cancelled. Starting with 3, if I write 3, the next prime number is 5. 5 and 3 is 8. So how much do I have to add into 8 so that I get 21? Think about it. So 5 and 3 is 8, and in this, if I add 13, which is also a prime number, you see, the sum is going to be 21. So these all three of them are odd prime numbers. For 31, if I start with 3 and 5, that is 8. So how much do I need to add now? 23. And that is 31. So 3 and 5 and 23, they are forming the sum as 31 and the 3 are 4 primes. C part is 53. Okay. With 53, if I try with 3 and 5, you will not find the third number with which like 3 and 5 is there. 5 and 3 is 8. You subtract 8 from this. Okay. 13 minus 8 is 5 and it is 45. So 45 is not odd prime number. It is odd but not prime. So we have to think about some other pair. So when you think about the other pair, you will get 13, 17. You can see 13 plus 17 is 30. How much do I need to add? 23. So yes, these three are odd prime numbers. So 53 is now expressed as the sum of odd prime numbers. The D part is students 61, and for 61 you will find 7, 13 and 41 whose sum 7, 13 and 41 whose sum will be 61. Okay, and these three are odd prime numbers. So this way you have to figure out, like you can start with 3, then you can add up 5 and see if that triplet is working. 3 pairs, three numbers when we write, it is not called a pair, it's called a triplet. So three you have to write. So you need to think about what triplet will work for it. So you start with three and then write five and then try to add number, or you see how much is left. So like we did 45. Okay, 45 was not a prime number, so we did not take it, so we had to figure out some other triplet. Okay, and that became 13, 17 and 23, like that. Moving ahead with the next question. Five pairs of prime numbers and they should be less than 20 whose sum is divisible by 5. What I'm saying, five pairs of prime numbers. When you add those prime numbers, their sum should be divisible by 5 and those prime numbers should be less than 20. So less than 20, the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. These are the prime numbers. Okay, we have to write pairs of prime numbers. Okay, and they should be divisible by 5. So if I take 2 and 3, if I add them, what I get? 5. Yes, it is divisible by 5. One example they have given, 3 and 7. So yes, that is divisible by 5. Okay, with the 2, can I form any other number so that it is divisible by 5 then? So let's figure out. With 2 it is 3, it gave us 5. With 2 if I add 5, that will be 7, not divisible by 5. 2 with 7 would be 9, not divisible by 5. 2 with 11, not. So when you try with two other numbers, you will not get the sum which will be divisible by 5. With 3, we see 7 is working out. And with 3, if I do with 11, 3 and 11 will be 14, not divisible. 3 and 13 would be 16. 3 and 17 will be 20. Yes, 3 can be written with 17. 3 and 17 is 20 and this sum would be divisible by 5. So we've got another pair. And if you try with 7 and suppose I try with 11, 7 and 11 gives me 18, not divisible by 20. 7 we can try with 13, that 13 and 7 we have already taken, 3 and 17. Okay, 3 and 17 we have taken, so 7 and 13 will give me 7 and 3 10, so it will give me 27 and 13 we can take it, it is giving us 20 as the answer and divisible by 20. So this is another pair. This was 3 plus 17 and this is 7 plus 13. The next that I can take up is, let's figure out 13 and 17. What about 13 and 17? So I'll get 10 plus 10, 20, 30. Is it divisible by 5? Yes, it is divisible by 5. So we have got one more pair, 13 and 17, which are prime. And we are getting the sum as a number which is divisible by 5. Okay. Okay, with 13, you can, try with 2. So 2 with 13 would be 15. That is also divisible by 5. So students, you have to try 2 with all the prime numbers, then 3 with all the prime numbers like this, and you'll get many pairs. So they asked us to write any 5. We have written 5 pairs. Let's move to the last question for today. It is Phillips. Okay, and we have to write down the answers. So let's get started. The first one, a number which has only two factors. Only two factors is called a prime number. We have discussed it. Okay. The second one is a number which has more than two factors. If it has more than two factors, it is not a prime number. It is a composite number. Okay. The next is one is neither dash nor dash. Neither prime nor composite. One is neither prime nor composite. Yes. The smallest prime number is, I have discussed it with you, the smallest prime number is 2. The smallest composite number, okay, prime number is 2. One is neither prime nor composite. 2 is prime, 3 is prime. Then composite number starts with 4. So 4 is the smallest composite number. The smallest even number is 2. Clear? So this is how we have answered and applied our knowledge of prime and composite numbers. So that's all for today and stay tuned. Thank you.